So today we're just going to kind of go overall strategies for solving FRQs, specifically the experimental design question, which people typically do the worst on. So I wanted to go specifically over things that I recommend. So first and foremost, and I'm going to drop this in the chat here, and I guess I could drop the link in all Google Classroom, but this link here, if you go to this link, you will see all the past exam FRQs. So all of them in AP1 have all the past FRQ questions, so you can practice those, because I think that's one of the best ways for you to practice. After we're done here, if you want to get some more practice, I strongly recommend it. Also, I think a really good resource is Mr. P has done full solutions for all of the questions and even noted which topics are removed, so you know which ones are good to do, which ones are unnecessary to do. I'm going to drop that link in here too, so you can do them and then you can see solutions and how to go through the problems. But what I thought I'd do is go through general strategies, and then we'll do an example together, and then I'm going to have you do a practice FRQ experimental design question. So with these questions, people typically don't know where to start. So the place to start, and I will show you my my hover cam. Oh, it's not here. The place to start is start by looking at all the possible equations, and then equipment. How to start? I'd say start by looking at equations. Then think about equipment to use to measure these things. So in our Google Classroom, we have posted the equations. They're in the resource section. The equation sheet's right here. So if you look, you can see, okay, this is where all the values are, and here are all the equations. And it looks like a whole lot, but it's really not that much relative to what we've learned. So you can look through here to find that. Also in there is something called the, where did I put it now? Here, it's called AP Physics 1 Variables, and I'm going to even call it AP Physics 1 Variables / equipment. So you can start practicing looking at what variables we could use in physics, and then what equipment we would use to measure it. And I've highlighted ones that I think show up frequently in experimental design questions. So if they ask you about force, you could use a scale or a spring scale or a force probe. We haven't used this necessarily, but we've talked about these ones. If you need mass, you need a balance, and these are the units. If you need time, you can look at a stopwatch, or use a stopwatch or a photo gate or video analysis. If there's speed or velocity, you can again use video analysis, a motion sensor, or photo gates and a meter stick. This is very typically used, is just photo gates and a meter stick, where you look at how long it takes to go through something and you measure how loud the object is. Height is, again, meter stick, probably not calipers too often. Laser guides, maybe, but this isn't going to be in a normal physics room. But video analysis, you could utilize for height if you really needed to. And I think that's the other ones. The ones down at the bottom aren't necessarily going to be that helpful. But this is all equipment that you could use for setting things up. So I would practice looking up things that could be used to measure these equipment. Then figure out, determine which equipment could measure your variables. And then use equations and graphs to solve for the answer. Special note, slopes are usually what you're after, but sometimes area is necessary as well. So these are good, just general strategies for experimental design questions. And I'm going to go through the 2017 question and talk about how to do that. So first and foremost, I'm going to pull it up. So that 2017 question 2 was a, let's see here. 2017 question 2 was a question where you had to design an experiment. So in the question, it said a student wants to determine the coefficient of static friction between a long, flat wood board and a small wood block. So describe an experiment for determining the coefficient of static friction between the wood board and the wood block. Assume equipment usually found in a school physics laboratory is available. So the first thing they wanted you to do is to draw a diagram of the experimental setup of the board and the block. This often happens. In your diagram, indicate which quantity would be measured and draw or state what equipment would use to measure each quantity. And then it says describe the overall procedure to be used, including any steps necessary to reduce experimental uncertainty. Give enough details so that another student could replicate the experiment. So sometimes they just write it like this. In the next question where you're going to try, sometimes they want you to actually list out what the equipment is, what you're measuring, and so forth. So let's think about this. So if I were doing this and going through my steps, first thing I would look at is the equation. Say, I don't know. I want to look at coefficient of static friction between two things. Okay, what equipment could I use? So I'm looking at my equations. Let's see, friction. Which one? Coefficient of friction. So which equation should we use? This one. Absolutely. So the coefficient of friction, or the force of friction, especially force of static friction, is going to be less than or equal to the coefficient of friction times the normal force. Okay. So I've got that, and I also probably need to think about normal force and how that's going to be related. But yeah, I think I could do this. And then if I'm dealing with forces, then I need to think about the equipment that I'm going to use. So in this case, I think forces, okay, a spring scale or a force probe or a bathroom scale. This, yeah, you could say these things are definitely equipment that you could use. Yeah. I would, the ones that I've put in red here, I would memorize. Just the equipment that you can use. Don't, I mean, anything that you haven't used, don't worry about that. But remember a spring scale is what you can use to measure force, or a bathroom scale is what you can use to measure force. Force probes are fine to mention. In fact, how I would probably set up this experiment, because I know, and also in order to figure out the normal force, let me draw this here. So if I wanted to figure out, I've got the wood. I wanted you to draw a diagram. So wood plank. Did I say wood board? And this is wood block. There he is. And then I need to figure out the force of friction, right? So I would use a force probe or spring scale, which I would label right here. Doesn't have to be a great drawing, but you could say, it specifically asks you to draw a diagram. So not all of them will, but sometimes they will. So we've got a spring scale to measure force of friction. And then as you noted, the force of friction is equal to mu times the normal force. So we need to figure out what the normal force is. So if I was doing this, you could draw a free body diagram. This is going to be Fg. This is going to be Fn. Yep, this is applied force, and this is the force of friction. In fact, specifying this wouldn't hurt. Spring scale to measure force of friction, because it will equal Fa. And then we could say our normal force is going to equal our Fg. So we need to measure, I would draw a balance. To measure mass, because Fg equals mg, which equals normal force. So I think this would get you full points for your description, but it asks you to specifically draw out everything. So you want to make sure you include both the things that you're looking at, the variable on. You want to make sure you have equipment to measure any forces. Yeah. There was another way to do it. I like this way, but you could also take the board with the block, look at the angle, and then measure the angle at which the block starts to slide. Using a protractor. That's how you measure angles. And you'd want to draw the protractor in. Or you could talk about something about, the height of the board relative to the length underneath it using meter sticks, something along those lines. I like this way, but Mr. P solves it using this way. So then the question asks you, keep losing my question. Dot diagram of the experimental setup of the board and the block. In your diagram, indicate each quantity that would be measured and draw or state what equipment would be used to measure each quantity. So just to make sure that I know that I'm going to be okay, here, I would maybe underline, okay. I know I need to measure force of friction, okay, because it will equal FA. And I know I need to measure the mass because it's going to equal the force of gravity, which will equal the normal force. So then it says, describe the overall procedure to be used, including any steps necessary to reduce experimental uncertainty. Give enough detail so that another student can replicate the experiment. So you're just going to describe what you want to do. So you could attach the spring scale to the wood block and pull until the block starts to move. Record the force right as it starts to move, because this is the force of friction. Now, it's specifically mentioned, and it usually will, you want to figure out, you want to limit uncertainty. So what do you need to do? Yes. Repeat this 10 times to decrease, yep, uncertainty. Uncertainty. Find the average. The average FF. Then measure the mass of the block, so the mass of the block using the balance, and multiply by the force of gravity to get Fg, which equals Fn. The last thing you want to say is explicitly talk about how you can solve for it. So you can say FF equals mu Fn. So mu S, I should put the S there because they specifically asked for static friction. Mu S equals FF divided by Fn, which I'm going to say so US equals FF over mg. I think that would earn you all points on this. You've drawn the diagram. Even if it doesn't ask you to draw the diagram, I suggest you do it so you can make sure that you have covered all your bases. You describe the procedure in a way that someone else should be able to do it, like you're writing a procedure for a lab. So attach the spring scale to the wood block and pull until the block starts to move. Okay, record the force right as it starts to move because this is the force of friction. You could probably even be more succinct than me. Repeat this 10 times to decrease uncertainty. Find the average force of friction. Measure the mass of the block using the balance and multiply the force by gravity to get Fg, which equals Fn. Force of friction equals force of static friction times Fn. So mu s divided by Fn divided by both sides, you get force of friction equals this. So US equals force of friction divided by mg. So that is how I think you would get full points on the experimental design question. Do either of you have any questions about that overall process? Because I think we're going to do one more, or one where you're going to practice it. Okay. All right. So I'm going to stop.